Hello, everyone. Thank you for joining us this evening. I'm Willie Costello, a data scientist, philosopher, and the AI ethics stream owner here at ACE. Now, for those of you who don't know, ACE is a global community of machine learning practitioners, researchers, and enthusiasts, founded in Toronto, Canada. We do a lot of different things here at ACE, but our mainstay is doing live sessions like this one, which we do multiple times a week, and which aim to showcase the latest and greatest in AI and machine learning research as a way of making it easier for everyone to keep up with the best of what's out there. Now, we also organize social events to bring the AI and machine learning community closer together, and we run workshops to help you learn how to translate state-of-the-art research into practical applications. And to learn more about everything we do here at ACE, please visit our website at ai.science and subscribe to our YouTube channel at ML Explained. Okay, so tonight I'm very pleased to welcome Emily Denton, a research scientist on the ethical AI team at Google. Now, prior to joining Google, Emily received her PhD from New York University, where her research focused on generative modeling of images and videos. Her current research agenda focuses on critical examinations of the histories of machine learning datasets and their associated practices of development and use. This research agenda is also precisely what Emily is here to talk to us about tonight, in a session we've titled The People, Politics, and Histories Behind Machine Learning Datasets. Now, more specifically, this is going to be a discussion of Emily's recent paper, Bringing the People Back In, Contesting Benchmark Machine Learning Datasets, which was presented earlier this year at the ICML workshop on participatory approaches to machine learning. Now, I'm really excited to have Emily here with us to talk about this paper, because I think this paper is doing some really critical work to change the way we approach a foundational issue in AI ethics. You're probably familiar with the fact that discussions of fairness and unfairness in machine learning often point the finger at the datasets on which machine learning systems are trained, and rightly so. Such discussions, however, typically focus on the content of these datasets. For example, how these datasets misrepresent certain groups of data subjects, or how they encode historical biases. But if we're really concerned about fairness and unfairness in machine learning, we shouldn't only be focusing on the content of machine learning datasets. We also need to be thinking about the creation of these datasets and the histories, values, and norms that get embedded in this process of creation. And this is precisely what Emily is going to bring our attention to tonight. Okay, so a few quick words about the format of tonight's session. Emily will begin by presenting her work for approximately 30 minutes, uninterrupted. The remainder of the hour will then be devoted to discussion and Q&A. If you are tuning in live and would like to participate in this discussion, please do so and submit your questions in the live chat. I will be monitoring this chat window throughout the session, and I will happily relay any questions you have to Emily. Okay, and with that, I'll now turn things over to Emily.
Awesome. Thank you so much for that introduction. Really happy to be here tonight. So yeah, I'm going to be presenting this work, Bringing the People Back In, Contesting Machine Learning Datasets. This is joint work with a group of really incredible folks, myself, Alex Hanna, Razvan Amoronesi, Andrew Smart, Hillary Nicole, and Morgan Klaus Scheuermann. And these are folks who are all spread out across Google, University of San Francisco, and the University of Colorado Boulder. All right, so I think Willie did a...
Are you sharing your slides now?
Yeah. Oh, do you not see them?
I don't see them.
Oh dear. Okay, let me, I don't know why it stopped, but let me go back. Thanks for flagging that. Awesome. Do you see now?
Yep, perfect.
Okay, perfect. Thank you. Cool. So I think, Willie, you set this up really, really well. Machine learning systems, they're being rapidly integrated into a variety of domains, consumer technologies, healthcare, policing, employment, kind of list keeps growing. But kind of accompanying the narrative of progress and innovation, we're also seeing increasing numbers of examples of the ways in which these systems are failing marginalized groups. So I'm going to give a couple examples here that I think folks are probably familiar with. So in this seminal work by Joy, and Willie, she demonstrated the systematic failure of a wide range of facial analysis systems to recognize darker skin tones. More recently, Facebook AI researchers have demonstrated that publicly available object detection systems fail to recognize common household items in images coming from non-Western countries. So these are a couple of examples, but I think the list kind of keeps growing. And this has prompted a very needed investigation into who and what is represented in the various machine learning data sets that are underpinning these systems. Somewhat unsurprisingly, these analyses have been conducted on some of these benchmark data sets, and they found systematic biases towards white, cisgender, male, Western data subjects. Those are kind of the directions they're all skewing. So I've given an example here of the distributions of some facial analysis data sets, as well as the locations that images have been sampled from in some of the most common image classification data sets. And this has given rise to a proliferation of algorithmic fairness interventions that strive for more balanced representations of different sociodemographic groups. So this is an example of diversity in faces, which is a data set that came out a couple of years ago from IBM, aiming to provide millions of images across a wide range of sociodemographic groups. But these interventions can play a really key role in mitigating some kinds of algorithmic harms. But most of the failures that we're seeing with machine learning systems, the harms are not exclusively located at the level of who is represented in the data set. And very oftentimes attempts like this to kind of strive for this mythical, unbiased data set, just this diverse data set that's going to capture everyone. Oftentimes these are carried out through somewhat exploitative and non-consensual means. So what I'm going to be arguing today is that understanding and intervening in the harms of machine learning systems really requires interrogating the histories of data sets and data practices and the values and assumptions that are embedded in the data sets. So going deeper than these questions of who is represented, who is excluded. And this is a bit of an interesting paper because we actually provide kind of an introduction to a research agenda that is ongoing and is going to be taking place for many, many years to come. And so this is kind of setting up why this research agenda is really important and why the methodology that we have started to undertake is really appropriate. So this is the kind of three-part overview of what I'm going to be talking about today. Starting, I'm going to talk about how data sets act as infrastructure for machine learning research and development. This is going to draw really heavily on the work of Boker and Starr and other infrastructure studies literature. And I'm going to really explore the ways in which data and its associated practices of development and use operate as infrastructure for machine learning research and development. And then I'll talk about some core characteristics of this data infrastructure and argue that genealogy is a really kind of critical methodology to be leveraging. So let's dig into data sets. So data sets operate as infrastructure in a variety of different ways. So they're quite literally the backbone of individual machine learning systems. So I think all the machine learning practitioners in the audience are gonna, nod along when I say that, the boundaries, the decision boundaries of your machine learning system, they're going to be, defined by the images in your data set, the category. Your data is what determines your model. So, just an example here of the machine learning data set ImageNet, right? We have 20,000 categories, 15 million images, and everything that an ImageNet classifier knows about the world is coming from this data set. But data sets also shape how problems are framed and how concepts are operationalized. So, the notion of a trout in the ImageNet data set is a very specific notion of trout. So in this particular example, it looks a lot like dead trophies. So I'll kind of come back to this a bit, but this is just kind of teasing how these data sets are really shaping a very particular worldview. Data sets also, we posit, play a role of the model organism within laboratory studies. And when I say this, I mean, they kind of provide this readily available, simplified playground within which machine learning practitioners can make technical progress. But they often operate with some pretty serious conceptual and empirical gaps between the real world tasks. And these gaps become increasingly concerning when we realize that the vast majority of AI methods deployed in industry contexts have, for the most part, been developed, standardized, assessed on a very few benchmark data sets. Data sets also operate as measurement devices. So, the standard practice is to evaluate your model on a test set to understand and kind of estimate generalization performance. We also use data sets to measure, model performance as a way of stack ranking models and comparing models and determining, what is the current state of the art. And some of these benchmark data sets end up operating as very authoritative markers of progress, oftentimes actually orienting the goals of entire research communities. So the ImageNet challenge is probably one of the most canonical examples here, right? We really saw this challenge pick up steam, around 2011, 2012, when AlexNet entered the field. We saw that it started to be solidified as this go-to standard for evaluation, and the field kind of coalesced around it as a really important marker of progress within the field and a really important kind of testing ground for different sorts of algorithmic developments. And of course, these benchmark data sets and using these data sets as measurement devices, these aren't value neutral. So there's this really great work called Evaluate and Disciplinary Shifts in Machine Learning, where they discuss how the kind of commitment to the deep learning paradigm, which in large part came about through the coalescing of the community around ImageNet. This kind of commitment to deep learning as a modeling paradigm has both necessitated and instigated, increases in compute power, larger data sets, specialized hardware, components which are really only possible to obtain through large tech companies and major research universities. So just one example of how, these benchmark data sets are really structuring what people are doing and kind of creating affordances and incentive structures, but often in very value-laden ways. And of course, ImageNet is, not an anomalous example. All sorts of different subfields within machine learning now have their own benchmark data sets that kind of within those own communities structure research agendas, track progress within the field. So another really key aspect of infrastructure is that it has been built. Right? So this data infrastructure has been constructed, labored upon by individuals, within particular institutional contexts. And thus the data sets, are going to be inherently contextual and situated and shaped by specific means. So I'm going to talk a little bit about ImageNet here to kind of orient this a little bit and make it a little bit concrete. So ImageNet has been described as a project of mapping the entire world of objects, which is massively ambitious. But of course, this isn't quite right. ImageNet maps a very particular way of seeing, a very particular way of naming the visual world. It's not universal by any means. Different components of ImageNet have their own histories. WordNet, for example, is the ontological structure that shapes ImageNet. And it itself was constructed by psycholinguistics in the 1980s. It was an attempt to hierarchically organize the English language. And of course, all sorts of simplifications were necessary in order to actually, kind of compress the English language into some nice hierarchical structure. And so the WordNet itself is kind of situated within a very particular disciplinary practice, particular means, particular aims. Similarly, the ImageNet images, they come from a snapshot of the images, in the late 2010s. This data itself is also situated. It's shaped by the kind of practices of, digital image sharing on the internet, shaped by the types of things that people even choose to photograph to begin with, And then, of course, all the idiosyncrasies of the web search engines at that point in time. And then again, of course, there's kind of layers and layers on top of this. The annotations themselves were crowdsourced by Amazon Mechanical Turk workers. And kind of associating concepts with images is not a straightforward thing. There's a lot of interpretive work that goes into here. It goes into this process. And so, all of these different pieces are kind of coming together to craft a very particular worldview. So I love this quote here. To produce a data set at the scale of the web implies a particular way of seeing images, of pointing and naming. So this blog post kind of talks about all of these things. And they look at the ImageNet data set and they see how, hammerhead shark is framed within the ImageNet data set as a scientific object. Trout is framed as this dead trophy. Lobster is framed as food. And I want to emphasize these, sometimes stuff like this gets talked about using the word bias, but I think bias isn't quite right, because bias suggests that there's some, natural or universal or objective thing that we're striving for, and this is just some biased representation of it. But I think the point that we're really trying to get at here is that there's no way to construct, a massive set of images and organize them in a way that is going to be universal. There's always going to be some judgment, some interpretation of what this concept looks like and how we're going to frame it in the data set. But that kind of recognition, of these data sets as constructed and as situated is very often lost and kind of not acknowledged within machine learning practice. So I gave some, perhaps less, visibly problematic examples there with the hammerhead shark and the trout, just to kind of, ground what we're talking about. But we also see some pretty awful things coming out within the ImageNet data set. This great blog post, Excavating AI, I'd recommend folks go read it. Crawford and Peglin, who authored this, they really talk about a very particular kind of epistemic commitment within ImageNet, and one that's also reflected within computer vision more broadly. And they talk about how ImageNet really presumes this stable and universal relationship between concepts and images. And they describe this using the phrase of the weird metaphysics of ImageNet. And they have a quote which I really like. They talk about how there's separate image categories for assistant professor and associate professor, as though if someone were to get a promotion, their biometric signature would reflect the change in rank. And they also do a deeper investigation into a variety of different categories that are embedded within ImageNet, finding some pretty offensive and problematic categories, including slurs and derogatory comments. More recently, there was another examination of ImageNet that kind of dug into the non-person categories, but categories where people still kind of show up within the images. And found a lot of associations between women and bikinis and miniskirts in categories like that, whereas men were represented much more commonly with musical instruments, sports, and fishing. And they found a lot of the photography of women to be sort of voyeuristic and non-consensual in nature. So we see that a lot of these concerns are quite tangible and are really kind of impacting the representations of people in the world, and kind of not accounting for these particular views that get embedded in these data sets can have real serious harm. Okay, so I want to talk about this concept of naturalization. So this is a concept that comes from infrastructure studies. And infrastructure studies, they talk about how working infrastructure over time tends to disappear and just kind of seep into the background, at least for the folks, for whom the infrastructure is working. And we see this with data sets as well, I think, where, as data sets become increasingly familiar to researchers, they just kind of seep into the background, of our daily work environments. We don't have to think too critically about, our choices when it comes to picking a data set. So, to say that a data set has been naturalized is to say that a data set has lost this situated and contingent nature. So everything that I was talking about with ImageNet, right, it is constructing a very particular view in the world. It has come out of a very particular socio-historical context. But you can import ImageNet with one line of TensorFlow code. And for the average machine learning practitioner, I've definitely done this. It's like, oh, I need a data set. This is the data set that I use. I'm just going to import it. I'm going to use it. Maybe I choose my data set because I want to have, I want to be able to report state-of-the-art results. And, this is the data set that everybody's evaluating on right now. Maybe I pick my data set because I'm really interested in the particular task it represents. But by and large, we aren't kind of confronted with these histories and with the very value-laden origins that a lot of these data sets have. So I think that our current data set development practices also hasten this naturalization process in a lot of different ways. So there's been some work coming out recently that's been empirically analyzing data sets coming out of the natural language processing community, as well as computer vision data sets, and kind of finding overwhelmingly that data decisions tend to go heavily underdocumented. So, who is annotating the data? What are the categories? Why were they chosen? In other sorts of details like that are really kind of just left unsaid. And categories, by and large, tend to be presented as fairly natural. This is a kind of pervasive pattern as well. And even highly political categories like race and gender tend to be presented as indisputable and natural. Also, the annotation and labeling is rarely viewed as interpretive work. So I kind of talked a little bit earlier about how, deciding what is a hammerhead shark and what is a hammerhead shark going to look like in my data set. That is interpretive work. If you're asking somebody, is the concept present in this image? By and large, that's not going to be an objective question. It's going to depend on the context in which the question is being asked. It's probably, depending on the kind of positionality or subjectivities that annotators are bringing to the task, they might respond differently. And I think, very often dataset developers and machine learning practitioners kind of view the answers to a lot of annotation tasks to be sort of self-evident, and believe that there's some underlying truth to it. And then if annotators disagree, there might be noise or they may be making mistakes. And I think this notion that, there is no singular truth. There might be sort of different interpretations and different answers to a question, and different annotators might bring different perspectives. Kind of really recognizing that and accounting for that is something that, by and large, is missing right now. So some other data set development practices that are really kind of hastening this naturalization process are the patterns of valuation that I think are operative in the field right now. So data work is heavily, heavily undervalued relative to model work. This is kind of, evidenced through a variety of different mechanisms. We see that data sets that are focusing on publications tend to be heavily devalued within peer review processes. This is kind of in contrast to model work, right? If you have an algorithm that you've developed and you achieve state-of-the-art performance, you submit that for publication, it's probably going to go through. But data set or publications that are focusing solely on resources without kind of cramming in these modeling developments very rarely are valued in the same way. And machine learning textbooks and curriculums, also don't treat data set development as a specialty. So this recent paper here is examining kind of differences between data set development practices in machine learning and in archival fields. And they kind of characterize our attitude as fair egos. Whereas what we should be doing, they argue, is kind of moving a little bit more into this kind of careful curatorial mode of data set development that is more sort of reminiscent of archival practices. So that's the kind of main kind of thesis that we're putting forward here, which is that these data sets have been shaped by these processes of naturalization. And one of the key consequences here is that this really limits the kind of avenues of contestability that are available. So, you know, to put it a different way, once we've lost the history and kind of context, we view these data sets as kind of, value neutral, uncontestable black boxes. We're just kind of adopting them kind of daily within our routines. And this makes them really, really hard to kind of challenge and push back against and probe. And it also limits the space of critiques that are kind of available. And in doing so, limits the space of possible interventions. And so, I mentioned earlier how a lot of data set oriented fairness interventions hinge around this notion of increasing diversity in data sets or kind of balancing demographic distributions. But again, kind of focusing on these, kind of statistical properties of data sets at the expense of, interrogating the underlying data infrastructure in its full complexity, we're really kind of privileging some critiques over others. So ImageNet actually has responded to the critiques that were put forward in the excavating AI piece. And they responded in a very commendable way. I really, in this, I sort of want to say a little caveat here. We talk about ImageNet a lot in some of our sort of forthcoming work. Because the ImageNet creators have been really transparent with a lot of their documentation and with a lot of their kind of remediations to the challenges that have been raised. And so while we are kind of somewhat critical in terms of how far they're pushing things, we really kind of commend the authors for doing that work because we aren't seeing that very often. But in response to the excavating AI work, a huge number of images were removed. And some of the solutions, the other solutions focused on filtering and balancing the data set. And so what we're seeing here is the kind of response fitting in within this idea that, okay, we just need to balance demographic distributions, maybe throw away some, really challenging and really, offensive categories. But, not quite kind of questioning, what does it mean to associate concepts with images and really kind of probing some of the deeper ontological questions with the data set. So yeah, this is really just kind of restating what I've said. We really want to move beyond focusing on these statistical properties. Not that they're not important, it's also important, but it's not sort of singularly important. And we really want to examine the contextual and contingent conditions of creation of these data sets. So this brings me to our kind of ongoing research agenda. So we focus on this method of genealogy, which is it's an interpretive method, and genealogy was proposed, or the method of genealogy that we're leveraging was proposed by Foucault. And we leverage this method as a way of denaturalizing this data infrastructure. So by kind of looking into the histories of these really prominent data sets, by investigating and kind of making visible these histories, making visible the value-laden decisions, making visible the fact that these, are situated and constructed entities and not these kind of value-neutral artifacts, we're hoping that we'll be able to kind of denaturalize this data infrastructure and open it up for new avenues of contestation and intervention as well. So I'm actually going to kind of skip this side. This is a little bit more for the STS scholars in the audience. We do, in a kind of upcoming paper, we do a little bit more theorizing as to the relationship between genealogy and other kind of modes of investigating infrastructure. But we can maybe come back to this in the discussion. So I want to outline this research agenda. So this is what we put forward in the paper. And as I mentioned, this is kind of an ongoing research agenda. So our first core question is around understanding how dataset developers describe and motivate the decisions that go into dataset construction. So Morgan, who I mentioned at the outset, is an author on this paper. He's been leading a lot of the empirical work that we've been doing here, examining texts that are associated with over 100 computer vision data sets. And in an effort to kind of illuminate the motivations, kind of spoken and unspoken conventions of data set construction, curation, and annotation. And this is something that, we can also kind of come back to in the discussion, but we're finding a lot of really interesting patterns here, a lot of which are kind of, confirming some of the hypotheses that we had coming into this regarding, what folks value in data sets, and what goes unsaid in the data set publications that are accompanying these. So another question that we're really interested in is just what are the histories of some of the most prominent benchmark data sets. So we've been focusing on ImageNet thus far, kind of examining both the dominant narrative surrounding the data set, as well as the kind of the histories that are less told and are less visible. But are still integral to a genealogy. And in the future, we hope to extend this to other foundational data sets, kind of interpreting their histories and interviewing their creators and other folks who have kind of labored upon them. So another question we're interested in is how some benchmark data sets kind of become authoritative, and how this actually impacts research practice. So I gave ImageNet as an example of one of these authoritative data sets, one of these benchmarks that really, really kind of fundamentally reoriented the field of computer vision and the field of machine learning more broadly around a very particular modeling paradigm. But, ImageNet doesn't stand alone. And we're really interested in kind of examining these practices of state-of-the-art chasing or SOTA chasing and the kind of implications that this has for the field. And something that I'm quite interested in here is, and again, maybe we can kind of come back to this in the discussion, there's been growing critique from natural language processing communities regarding the kind of singular focus on benchmark metrics. We haven't seen quite the same concern from computer vision communities, not to say that it's not quite there, but we are seeing the kind of different fields kind of engaging with benchmarks and engaging with SOTA chasing in slightly different ways. And so I'm interested in, both the overall questions and then kind of the subtleties of how different subcommunities in machine learning operate with respect to these benchmark data sets, and the degree to which these benchmarks kind of, exist in this kind of authoritative manner. And then finally, we're really interested in understanding what the current work practices and norms and routines are that structure data set development. So this is work that we have not yet started. This will probably be a little bit in the future, but what we're hoping to do is perform multi-sited ethnographic work kind of centered around some of the major computer science hubs that have contributed to this data infrastructure and that are kind of currently underlying the machine learning models that are being deployed in practice. So I think that's all my slides. Yes, that is all my slides. And just, thanks to some folks. So most of the folks listed here are on the workshop paper. And then there's a few others who sort of Timnit, Ben, and Meg, who were not collaborators on that work, but are colleagues of mine and are doing really awesome work kind of in this space. And a lot of these ideas, kind of come from chatting with them. So I wanted to give them a shout out as well. And that is it for my slides. And I think I stayed on time and excited to pick up on lots of different threads here in the discussion.
Yeah, that was fantastic. Thank you. That was such a great overview and actually like a deeper dive into the paper. I think you've provided like so many rich examples for us to chew on, but also this great theoretical framework. So I want to jump right in and come back to something you said around the middle of the presentation about ImageNet. And you said something to the effect of like, there is no way of constructing a data set that would live up to the ambitions of ImageNet, a data set that would actually map the entire world of objects. And I think this is a really critical point in what you're saying that because there are always these choices of framing, of how we're presenting all of these objects, there's no way to do this in whatever, a completely objective, or I don't know even what the words are. But okay, so we can create different versions of ImageNet, but we're never going to arrive at that real ambition. My question for you is, okay, what does this then mean about the ambitions of computer vision models?
Yeah, so I might have like a little bit of a controversial or unpopular opinion, but we'll try. I'm going to throw it out there, and I want to kind of caveat this with my background as a researcher is as a deep learning practitioner. I did my PhD at NYU studying sort of generative models of images and videos. And I tended to consider myself more of a deep learning researcher than a kind of computer vision researcher. But computer vision is where I was kind of doing most of my kind of applied sort of work. And I was really excited by image classification systems, and I was really excited by ImageNet. So I just want to emphasize that like my views have very much shifted in the past couple of years, when I've kind of just examined a little bit deeper what are the kind of epistemological commitments that are embedded within this framework. So that's just a kind of position where I'm coming at this, and also that these are kind of ongoing thoughts that are being developed. But what I would really love, that I think the computer vision community isn't quite there yet, but I think we can get there. But what I would really love is to kind of recognize data sets as always inherently situated. So this idea of a universal benchmark, of a general purpose benchmark, I think is actually, I think it's both kind of an incoherent goal and also maybe the wrong goal. And that's not to say that ImageNet hasn't been really kind of meaningful and impactful within the field. And that's not to discredit the work that went into the development of ImageNet, right? ImageNet has created kind of testing grounds for so many algorithms and so many different models, models that are applied both in computer vision and outside. So again, it's not to kind of discount or discredit ImageNet's kind of value within that framework. But I think that when we frame benchmarks as these general purpose benchmarks, then the claims that get made in kind of in reference to state-of-the-art performance on these benchmarks very much misconstrue what the benchmarks are actually doing. So ImageNet, for example, there have been a lot of claims made. I think I actually might cite some in the slides, which we'll share, and all the links are clickable. But there's been a lot of claims that like, oh, because we're able to perform so well on ImageNet, we're like, epsilon away from the AGI. And I know that like a lot of this is hype, but it's also kind of coming from within the community, and the community is shaping public discourse, and we're shaping, kind of what gets built and how things get built and how things get tested. So I think it is really important to be careful about these things. And what's interesting is that, Pascal is, kind of the benchmark that was in place prior to ImageNet, and Pascal had, I think, like 20 categories and maybe like 20,000 images. We actually listed in the paper, but it was quite small in comparison. We weren't seeing the same kinds of claims being made about performance on Pascal. But all of a sudden, ImageNet is kind of claiming to be comprehensive, and it's very impressive. Like doing well on ImageNet, means that you've built a really powerful, pattern recognition system, which is, it's kind of meaningful to make certain claims based on performance on ImageNet, but claiming that like, we can now recognize like, all of these different categories anywhere in the world, that's not accurate, right? And so I think this kind of brings up another subtle point around kind of the ways in which we communicate these benchmarks and the ways in which we kind of situate, and then we are really careful and attentive to what state-of-the-art performance on that benchmark means, and being really kind of precise when we communicate that. And I think this is work both on the side of dataset creators and of benchmark creators to kind of do the work up front to make sure that the claims that get made from state-of-the-art performance are actually related to the thing that the measurement is indicating. And then this is also, something that the community at large, can play a role in, because sometimes benchmarks get put forward and they are communicated in pretty clear ways, but then they get leveraged and claims get made. And the field also moves at a really rapid pace, and we kind of, there's these bandwagoning effects around certain benchmarks. So that would be my kind of take on that, is that general purpose benchmarks don't make sense. Again, doesn't mean that like something like ImageNet isn't useful in some cases, but to cast it as a general purpose benchmark is actually misrepresenting what it's doing, and I think can kind of lead the field in, sometimes dangerous directions. And then second, when you're creating data sets, just being really, really intentional about what is this capturing, what is it not capturing, how am I going to communicate that to the data set consumers, and how am I going to, really kind of account for the limitations of whatever is being put forward in this data set.
Yeah, that makes so much sense. And I mean, it sounds like one of the things like that would ideally come of this communication of, the genealogy of any data set is, ideally you'd want a sort of circumscription of what the model is actually doing. So it's not just, it's not a model that's able to classify and see anything, but actually it's much more narrowly construed. And I think there's an analogous thing happening right now with GPT-3. And is this understanding or is this something else? And so a lot of the discussions that, Emily Bender has been having about this, I think are really similar. And like these claims matter in terms of what we are really claiming the models are doing, right?
Yeah, I completely agree, and
Yeah.
I'm really glad that you mentioned Emily Bender's work, because I think that that's critical, and I think we need to have I'm seeing so many fascinating conversations coming out of the natural language processing community, and I'm like, we need to have this in computer vision as well.
Yeah,
a lot of the issues are quite analogous.
yeah. Okay, I was going to ask a different question. We'll come back to that. But just on like the point of of the natural language processing community, I think part of what's going on there is you have voices like Emily Bender, who's like a trained linguist and has this like really deep subject matter expertise, and I see in her work that she's bringing that to bear. Now, one of the things I love about your work is, it is very interdisciplinary in nature, both in what it does and what it's advocating for. I just wonder, has there been, well, I don't think there has been that same like interdisciplinarity infused into computer vision work. And I wonder if that's part of the problem, or what do you think about interdisciplinarity?
Yeah, so I have a lot of thoughts here. I do think that's one of the critical problems with computer vision. So something that I would love to get to as part of this genealogy, we'll see, if or when we get there. But I really want to trace the kind of histories of computer vision and natural language processing as fields. And I'm interested in this because I did my undergrad in cognitive science and computer science. And so I kind of got into AI through a cognitive science perspective. And both computer vision, I guess AI as a whole, kind of has deep roots in cognitive science and is now, I don't want to say sort of drifted away, because there's a lot of AI research that is still tied to cognitive science, but it's kind of forked in some ways, right? And so now we have a lot of AI research that is kind of, not even really related at all to the kind of goals of the field of cognitive science. And computer vision and natural language processing have kind of followed their own independent paths. But I think, natural language processing has always had this kind of connection through linguistics to this very different mode of thinking about the problems in AI. And there isn't really an analogous field within computer vision, right? There's sort of studies of perception and studies of the visual system, but that's not really what computer vision is, right? Computer vision is about, kind of perceiving, but also making sense, interpreting. And yeah, we don't really kind of have that grounding to another field. And I think, I'm really interested in doing some comparative analysis between the two fields and between the data practices that have kind of emerged within the two fields, because I see, very often, the fields kind of run up against similar concerns, obviously kind of manifesting in different ways, but similar concerns. And we see the two communities reacting in very different ways. So even like not even thinking about, data sets per se, but just kind of broader ethical concerns regarding, the development of, various kind of technologies and the kind of growing awareness of the societal impact of this work. I think the natural language processing community has really kind of grappled with those concerns in a very different way than the computer vision community. I'm also, I'm speaking about these as though these communities are like monoliths, which is obviously like super reductive and, overly simplistic. But the kind of like high level patterns, we see in the natural language processing conferences, entire, conference tracks being dedicated to ethics and a lot of workshops popping up. And I think we're starting to see this in computer vision fields, but again, they're kind of happening at very different paces. And I think also a lot of the critiques that are coming out about, state-of-the-art sort of soda chasing and about the singular focus on benchmarks, a lot of those are coming from folks who have kind of grounding, in these linguistic traditions and have really rich domain expertise that they can kind of lend. And what's the analog in computer vision?
I was thinking if there was an analog, it would be photography.
Yeah, I mean, so we do talk about in the oh wait, no, we don't actually talk about this in the paper. We talk about this in a paper that is coming up that will be released soon. But right, there are entire fields that are dedicated to thinking about the kind of relationship, the like ontological kind of complexities, between images and their meanings, right? Because like these meanings are really complicated, they're mediated, they're contextual, like art historians, media studies scholars, right? Like all of these folks are thinking about this, hermeneutics, like all the, like people are thinking about it, but it's not quite coming into the field. And I think this is another sort of interesting thing, I think, which is with the natural language processing community, we don't have people outside the field coming in and being like, hey, like stop doing this thing, because linguistics and natural language processing, like they're kind of, they have this entangled history. And of course, there are some folks who are kind of more on the computational linguistic side, and some folks who are maybe more on the kind of methods like AI side. But folks from different communities come together in these conferences, and so there is this much deeper coupling. Whereas the folks who are kind of thinking deeply about meaning and imagery, they're not entangled with the computer vision community. And maybe they should be, and maybe that's somewhere we should go. I think just to kind of answer your higher level question of like, interdisciplinarity, how should that be valued? I think my answer is going to be, not shocking at all, but I think we should value it. There's a kind of huge hierarchy, of knowledge within the field right now. There's a lot of the kind, I mean, I guess this relates to the data work as well, right? A lot of the kind of specialties that would need to be brought in to be really careful and thoughtful, with the development of data sets. These are kind of methodologies that have been developed in other fields that are working with data and are working with data about human subjects, and working with data that is kind of representing our social world in really complicated ways. And there's a lot of really, careful ways of thinking about doing that work. And we need to bring that into the field, right? But it kind of starts with like valuing, the kind of outputs of these different fields and of these different bodies of knowledge as valuable, as important, as meaningful to machine learning work.
Yeah, absolutely. And I mean, I think one of the really nice things about your work is that it makes a very good case for why we need to be valuing this stuff. Okay, I want to go back to this question I had earlier about ImageNet and computer vision models, because I mean, this is more of a question that I'm imagining someone having, than a question of my own. But you might say, okay, like let's be suitably modest and circumscribed about what ImageNet is, what our models trained on ImageNet is. But look, like in most cases, in most actual applications of computer vision algorithms, we're not just kind of deploying ImageNet trained models like out of the box, just right on the world and, classifying now lobsters or trout and everything else under the sun. No, we're using these models that have been trained on ImageNet and then doing some transfer learning and training them further. And I imagine some people will think of this and think, yeah, and so, there's what sort of downstream effects should we be worried about here? Because we're going to, our model is going to be tuned on the specific task that we're doing. So the class of trout in ImageNet is not relevant to that. And yes, we need to be very careful and thoughtful about how we're conceiving of the specific task we're training our model on. But why is this stuff you're saying about ImageNet relevant to what I'm doing as a further downstream ML practitioner?
Yeah, so I have a couple of different answers to this. One of them would be, ImageNet, has a material kind of impact and effect on the world, right? Through transfer learning and through things like this. And I think that I don't want to discount the importance of that. I know that most, computer vision systems that are probably deployed in industry contexts have their own proprietary data sets, which we don't have access to. I hope they're doing good things. Maybe they're not, we don't know. But ImageNet does actually get used quite a lot as a base model for a lot of things. And so, some of the representational concerns that kind of filter in through the ImageNet data set have a potential to kind of propagate down. So that's the kind of, and I think the concerns there, people, I think, kind of get that, right? It's a little bit more tangible to kind of think about, okay, what does the representation in this particular model mean for this particular user? But I think the less tangible and kind of more symbolic effect that ImageNet has had is relating to the kind of formulation of object recognition or of image classification, that it kind of puts forward. And this is where I think we really need to be careful about the ways in which we are framing and kind of describing the tasks that are embedded in data sets. So ImageNet, kind of puts forward this understanding of object recognition through a very kind of decontextualized, non-situated account of human vision. And so this is something that we've kind of been exploring actually in our kind of investigation of the discourses that are surrounding ImageNet. But a lot of the kind of documentation of ImageNet, the kind of initial publications accompanying the data set, as well as retrospective talks that have come from the progenitors, a lot of it really signals this deep kind of commitment, this deep epistemological commitment to the self-evidence of the labels between images and the categories in the data set. And this kind of, again, I've kind of brought up the kind of interpretive role and the subjectivities that are inherent in kind of naming things in the world, and this really kind of discounts that. So I think this is really critical because ImageNet, ImageNet has actually, by Fei Li, who is the kind of one of the main progenitors of this data set, she's described ImageNet as being, or she's described image classification and object recognition as being this North Star of the field, and of ImageNet kind of operating as this canonical task. And so here we see the particular formulation of image classification, which ImageNet puts forward, has basically been established as the de facto way of framing image classification, right? And it's not the only way to frame image classification, right? You could imagine kind of problematizing this this thing in a different way. I'm not quite sure what it would look like, honestly. It's kind of an interesting thought experiment. What would it mean to, essentially start from the place that naming and describing images is a situated and contextual activity? What would it actually formulate the through that lens and then move forward, right? So I think here, this is, again, a little bit more of a symbolic impact that ImageNet has had, but it has played a huge role in structuring how we think about this problem. And that in turn shapes how industry practitioners, other researchers, so on and so forth, frame this problem and actually kind of approach it in practice.
Yeah, that makes a lot of sense. And so it brings something else to mind that I've been thinking about this week. So I mentioned to you that there's been this Twitter thread and blog post a couple days ago about the Duke Mtmc dataset. So this is a dataset of videos that were recorded on Duke's campus. There were various problems with the dataset. The videos were recorded outdoors, which they weren't supposed to be. They were released without appropriate privacy protections. They've been put to use in various surveillance applications. But that wasn't the point of this thread, this discussion. Like, that stuff's been known, and indeed the author of the dataset, has retracted it, following the backlash. But what the Twitter thread was really highlighting was that nonetheless, this dataset has still been used in over 100 papers in the past year. And part of the issue here is that there's a lot of data sets that have been derived from the original one. And, so the derived data sets haven't been retracted, or at least not all of them have. So yeah, I've just been thinking about, okay, what do we do about this long afterlife of data sets? And I mean, I might raise this as sort of a challenge to your work. Like, okay, even if we're doing all of this genealogical work and, we've got all of our model cards and data sheets coming out and this stuff is really well documented, what more needs to happen to really get the uptake, in your opinion?
Yeah, this is a really, really good question. So, I mean, I think, okay, so I'll say, like, I definitely don't have like the be all end all of the answer here, but I think that, like, in addition to, thinking about documentation and transparency and kind of, framing, our problems in particular ways, we really need to be thinking about like infrastructures of maintainability, right? How are we managing these data sets once we put them out into the world? And I think this has to also be coupled with thinking about kind of community-wide practices of data set development and use. So something like an IRB process kind of holds researchers accountable to a certain kind of ethical framework. I'm not necessarily sure that like the exact IRB process is what we want in this field, but I think something like that. And this is, I'm not the first person to say this. This has kind of come up a lot. But something like that, kind of creates this community-wide structure of thinking about how we create data sets, how we put them out there. And then also can kind of, accompany this longer term, like, where does the data set live? Who has access to it? What are the terms of use? Right now, there's like, it's both the kind of wild west, to take I think they use that quote in the archival paper, but it's both that kind of framing in the development of data sets, but also the kind of deployment and management of them. A lot of folks just like create a data set, throw it up on their website, and then anybody can download it. This is something that we've actually been investigating in the empirical work that's been sort of led by Morgan. We've been investigating a lot of publications and the associated kind of data sets the websites of computer vision data sets, and found like very few of them, kind of hosted, on data repository sites. For most part, it's like a professor or a student just like hosts it on their website. Not a lot of terms of use, not a lot of licenses, very few IRB kind of approvals that are discussed in the publications. And a lot of the data sets, actually, like, we couldn't even find them anymore. It's like you go to the link and it's gone. And of course, like, kind of accompanying all of this is that like anybody can download the data set and then you just like have it, right? So I think this is kind of unheard of in other fields that work with human subject data. And so like there are solutions to this, right? Like other fields that collect really sensitive data about people have extremely rigorous processes and extremely like standardized ways of managing this data and of retracting data sets and of updating data sets. I think this is another thing that is related to this question is like, data sets is this like static artifact right now is very standard, right? You kind of release them, they're there, you don't update them. And then maybe if something, comes to light, you fully retract it. And again, like retracting data sets that have really problematic contents, like, yes, that's definitely do that. But also like, let's put in the kind of care and develop the infrastructure in advance so that like, retracting a data set actually kind of has the ripple effects on the community that we would hope it does.
Yeah, that's such a great point. There is so much more that I want to talk to you about, but we are just about at the hour. So I do have one more question. It's a question that I end every session with, which is, okay, if you're looking at the next 5 years of AI ethics in this broad space, what do you hope will happen in the next 5 years, and what do you think will happen?
Oh boy. I feel like this is a tough question because like depending on like what day you hit me, I might be more optimistic and like more aligned with my ideal. Okay, so I think my ideal would be to, I mean, there's a couple of different things. So I think, folks are kind of, grappling with the broader societal impacts, of machine learning and AI technologies. There's kind of growing awareness here. But we also see a lot of it, a lot of the responses kind of constrained within, kind of very limited technical understandings of the problems. And there's been a ton of kind of pushback from folks outside of machine learning, kind of pushing it back against the rhetoric of like fairness and ethics and really calling for, deeper kind of discussions of justice and equity and really kind of understanding what the lived experiences of people, who are being impacted with by these technologies, really understanding those experiences. And so I think that like, moving forward, I would love to see, kind of greater awareness from within the machine learning community that, fairness is not a technical concept. Fairness can't be reduced to kind of, parity of, error statistics in your model output. But, we really need to be thinking about the impact in a very tangible way on marginalized communities and on communities who are, kind of most excluded from the development of these technologies. So I think that's kind of one piece. And then I would also love to see, just a real kind of like dissolving of a lot of the knowledge hierarchies that are in the field. AI, machine learning, it's a kind of simultaneously a social and a technical endeavor. And right now we're really kind of valorizing and prioritizing the technical aspects and devaluing the social. And I think that if this field is to kind of progress, both in like a kind of, equitable and accountable way, but also like an empirically like rigorous, like a scientific way. We really, really need to recognize what it is that we are doing within this field. And I think that just fundamentally requires recognition that this is an interdisciplinary field and, kind of shifting of incentive structures, shifting of education, shifting of all of these things to kind of account for that. So I think those are some of the things. And then I can finally just one third point is just like slowing down. I know that this is kind of antithetical to a lot of like tech development right now, but just like slow down. Like this field, we're not like a purely academic field, and I think even a lot of researchers like to think that like, oh, like I'm just doing the research, like I'm not building the models, but like it's all connected, right? The kind of line between industry and academia, I think, is actually really blurry and is kind of a false dichotomy. And so I think both industry practitioners and developers and researchers and folks who are more academically oriented, like just, we need to slow down. This is some of the stuff is really cool. And like, I remember being a PhD student and being like, I have to like publish the thing so fast in order to like get the paper because the turnaround time of papers is so quick. And like this, so I say this as something that like, it's hard to just like slow down, right? Again, this kind of requires, community-wide incentives and kind of shifting of like how we are actually doing things. But I think just generally across the board, slowing down, kind of working in these new incentive structures that, kind of encourage people to do this kind of slow, critical, reflexive work, will kind of bring the field in a, hopefully more accountable and, equitable direction. And then I think, like, where do I think the field is going? I think I'm honestly really encouraged by a lot of the stuff that I've seen in the past year. So I look at NeurIPS, I think is taking a lot of steps to kind of meaningfully grapple with these things. We saw the kind of broader impact statements being required in publications. There's a workshop this year that's actually kind of formed around the concept of that kind of broader impact statement, and generally thinking through what kind of accountability mechanisms do we want to implement within this field. So I think that having those kinds of conversations is really important. I also really love the retrospectives workshops that have been kind of coming out at NeurIPS and ICML and maybe iClear, I'm not sure. But anyways, they're kind of, coming around and having people kind of adopt this really kind of reflective and sometimes critical view on the field. So I think that we're doing good things, and that makes me optimistic. And similarly, I kind of talked about the pushback to the soda chasing, all of these things are good. I just I hope that enough people are paying attention to it, and that we can kind of shift the field and shift the incentive structures. Because again, so much of this is institutional, right? This is not, again, individuals have a role to play, but also we really need to refactor how we're doing everything and how we are valuing different forms of work. So I'm encouraged, but I'm worried that not enough people are paying attention right now. But I'm gonna end on an optimistic note, and I think that I want to have faith in researchers that we can all do better.
Yeah, I think that's such a great vision for the future, and I think you have given us some real reasons for optimism. So thanks for that. I did want to share that we had one comment from the audience in response to our earlier discussion. There was an art historian in our audience who was saying they think that there's a lot that art history could bring to bear on these discussions of computer vision, and they'd love to have a conversation offline to talk about this. So as one final question, how could this person or anyone else get in touch with you, follow up? What's the best way to get in touch with you for anyone who wants to?
Yeah, so I will share my slide deck with you, and then you can post it with this video, and my email address will be there. So just shoot me an email. I'm also on Twitter. I'm really inconsistently using Twitter, always trying to do a better job. So I don't know, you can also talk to me there, but honestly, email you'll probably get a response faster.
Okay, well, thank you so much for sharing your work and your thoughts with us tonight, Emily. So that brings us to the end of this session. Remember, if you want to find out more about the latest and greatest in AI and machine learning research, and especially AI ethics research, go to ACE's website at ai.science, follow us on YouTube at ML Explained, and look out for all the future events in our AI ethics stream. Thanks again for joining us, and good night.